What's up, my dudes? It's me. So, are you trying to get into building your own PC? Or are you just curious about graphics cards? You're hardware like me. Well, if you're like me, you might have trouble understanding this.
Looking at the specs alone, the RTX 4070 is pretty underwhelming. At just 295 millimeters squared, this is the smallest 70 class GPU that we've seen since the GTX 770, and with the same CUDA core count as the RTX 3070,
Or this.
RTX 4080 12 gig, that they unlaunched it, and now in its place, we've got the RTX 4070 Ti.
I like your funny words, Magic Man.
If you understood what all of them meant, this video is not for you. If you don't understand,
How do you do, fellow kids?
you're in luck, because I'm going to do my best to tell you everything you need to know about GPUs, what Linus just said like CUDA cores, and more, so that you can learn about the thing in isolation. However, I suggest that you watch the whole thing because it allows you to understand what those terms mean. On a more serious note, I am new to this type of content. I've never made something like this before, so the quality will not be the best. In fact, I've already made multiple cuts because I messed up so much. Second, this is educational content, which means I have a responsibility to give you all accurate information. Whenever I talk about something, I will flash the sources on screen, and those same sources will also be available to access in the description. Without further ado, let's begin. Now, the naming scheme of a graphics card. What does it actually mean? Let's take, for example, the NVIDIA GeForce RTX 4080. Well, there are three parts to this: GeForce, RTX, and 4080. GeForce is the version, it's a brand of GPUs, and GeForce is for general purpose gaming. NVIDIA has a lot of different ones: Quattro and Titan. Quattro cards are designed specifically for graphic related work, such as CGI or machine learning, and Titan has the ability to do both, which means it's the most expensive. I wasn't able to find anything that says Titan does both of those things. This is a statement directly from ChatGPT. I apologize for that, just a word of warning. Now, what does RTX mean? Well, if a card has RTX in its name, which is most modern NVIDIA cards, ray tracing is supported. If it's a GTX instead of RTX, ray tracing is not supported. So, what about numbers? You can see on the screen here there's a 4080 and a 4060. Let's focus on the RTX 4080. What does 4080 even mean? 40 is the series or the generation, and 80 is how high-end it is. The higher the number, the more expensive it is, and the better performant it is. Now, you may have noticed a TI at the end, right? So if you look at the high end, there's GeForce RTX 4070 and 4070 Ti. Ti stands for titanium. What does it mean? It just means it's better because it has a larger feature set. The larger feature set could include more VRAM or CUDA cores, which I'll talk about shortly. This also means there are two versions of the same card. Well, what about AMD? AMD is also another big name in producing graphics cards, but it's more simpler. In AMD's case, there's the AMD Radeon and the AMD Ryzen, and you only need to consider the Radeon because the Radeon are the GPUs and Ryzen are the CPUs. Pretty simple, pretty cut and dry. Onto the ray tracing support. As far as I'm aware, all GPUs by AMD, as long as they belong to Series 6000 and above, will support ray tracing so long as there is an RX in the name. I would like to point out there's no confirmation for this. It's just what I happened to find where this statement was made by ChatGPT. As you can see, I flashed a couple of screenshots of me searching for the term ray tracing on AMD cards before 6K. So there's the Vega and 5K, with Vega being the predecessor to 5K. For the 6K series and above, so 6K and 7K, the terms ray tracing do come up. To reiterate, every single AMD card after Series 6000, as long as it has RX in the name, it will support ray tracing. That was a pretty huge info dump, wasn't it? Once I understood the naming scheme, I was able to glean more information just by the name itself, and I hope that you'll be able to do the same. If you found this helpful, please give this a like and subscribe. If not, feel free to dislike, but I would also prefer it if you leave a comment explaining why, such as if something wasn't clear enough, or some things were just straight up skipped for those veterans here. Let's continue to the next topic, VRAM. It stands for Video Random Access Memory. To explain VRAM, let's talk about RAM first. If you don't know what RAM is, it stands for Random Access Memory, and it stores temporary data. So if you open Notepad and you just type whatever the hell you want in there, and then you just close Notepad, you know that you won't save anything, that all that what you wrote is just gone, right? It's just gone. If you do save the file, that's permanent. If you close Notepad, it's still there. That's what VRAM does. Instead of storing text, what you store is pixel data. So the more VRAM a GPU has, the more pixels it can store at once. The more pixels it can store at once, higher definition your gaming experience will be. Onto CUDA. What is CUDA? CUDA stands for Computer Unified Device Architecture, and it does two things. One, it allows users to write code for a GPU without worrying too much about the technical details. If you're a programmer, CUDA is basically an API. For the non-programmers, the best way to explain CUDA is with an analogy. Let's say you're driving a car. In order to turn the car, you just turn the steering wheel. All you need to know is that if you turn the steering wheel left, the car goes left. You turn it right, car goes right. Simple. You don't need to care about what happens when you turn the steering wheel. You don't need to care about the technical details, which is like the nuts and bolts and what's actually going on under the hood, literally. So if a programmer codes for a GPU without using CUDA, they need to understand what's going on under the hood, how the various parts interact. CUDA provides abstractions, and that abstraction allows users to be able to write code more efficiently. If the code in the GPU is optimized, the GPU itself will be optimized as well, and it will run faster. Since CUDA is a technology developed by NVIDIA, this is only available on NVIDIA cards. You don't actually need to know that detail. The reason I included it is because I thought it was cool.
To downtown Coolsville.
And there's something called a CUDA core. The more CUDA cores you have leads to that performance. Okay, now for the last part, can you hear how happy I am? Because this actually took a really long time to make. Okay, anyways, the final thing is called a DisplayPort. The newest port that came out in 2007 is called DisplayPort. Most modern GPUs have a DisplayPort port. Is that confusing yet? So, it is also backwards compatible with HDMI. The purpose of DisplayPort provides better multi-monitor support. Okay, so that's it. That pretty much covers all the chapters, and I'm going to talk about things I didn't cover, like right now, and I'm gonna leave this unedited because I'm lazy. So there are a lot of things that I haven't covered. One of them is something called Pascal and Turing. Pascal is a computer architecture developed by NVIDIA for their GPU specifically. So something like a GTX 1060, I think, it would have the Pascal architecture, and something later would have Turing. Pascal is pretty damn old, and so is Turing. They're on a new one, which I don't remember the name of, but I'll flash it on screen anyways. So yeah, I'll leave a link to Turing, Pascal, and the newest architecture, because I think it will be an interesting read for those who are interested. And yeah, that's pretty much the entire video. There's really not a lot of things that I have to say, other than pretty much just end credits. And boy, this was really difficult to make. Not difficult as in it was hard to research, it was just the entire editing process. I mean, just look at this. Like, this is all for an 8-minute video. And like, 10 I guess with all my rambling. Like, look at all this. Like, all these audio cuts is mostly just me messing up. And there's also a bunch of like and right of like me catching my breath, which is what you'll hear a lot of in this specific like final section. I guess I'll leave it in like this one part, but then I'll get rid of it because it's actually pretty annoying to listen to. But yeah, that's pretty much it. If you guys enjoyed the video, like, comment, subscribe, And yeah, if you guys want more, feel free to let me know. Okay, bye bye.